Hi, my name is Darcy, and I'm here to tell you about Lesson 6, Roving for Detailed Data. This lesson is part of the Exploring Venus unit of the Roads from Earth to Venus companion course. The guiding question for this lesson is, how can we use rovers and instruments to learn about a place we cannot visit? Like the other lessons in this companion course, it's going to follow the 5E instructional model, and I'm going to walk you through each of those E's in this video. In the engage section, we're going to try to gather students' prior knowledge and curiosity. And in particular, we're going to get them thinking about the information they would need if they were traveling to a new place, and then how that information might change if they were going to a place that they couldn't actually visit, like Venus. So in order to do that, students are going to start by examining a satellite image of a location and then creating a list of things they would want to know before visiting that location. Maybe it's the temperature or the surface conditions. They're going to have to decide what they can learn from the image itself, and then they're going to have to also think about some other sources of information they might need in order to gather the information that they want. Okay. Then they're going to start thinking about traveling to Venus, a place that they can't actually visit. They'll think about what information they would need to know, what sources of information are available from prior missions, and then what additional information might need to be collected for a current mission before it went to Venus. To prepare for this part of the lesson, you really just need a satellite image. We recommend you use the image if you did lesson 5, if you use the image that the students collected with their aeropods connected to the kites. But if you didn't do that part of the companion course, you can just use any satellite image of your area or another area of interest that you can collect using a resource like Google Maps. Okay, after that, students are going to begin by learning more specifically about NASA's upcoming mission to Venus called the Da Vinci mission. They are going to learn about the Da Vinci probe, which is going to travel through Venus's atmosphere and down to the surface. And then they'll compare the instruments on Da Vinci's probe to the sensors available to them in their robot kits. They're also going to start thinking a little bit about how to give their robot instructions by completing a pseudocode matching game, which helps them understand how to write plain language instructions for their robot and then match those plain language instructions to the type of code block type code that is used by the LEGO Spike rovers. If you choose to do that part of the lesson, you just need to print out the appropriate set of cards for your group of students. Okay, in the explain section, students are going to start learning how to write code for their robot. They will start out by reviewing the Earth to Venus Challenge course, which they will eventually be driving on. But we also provide some standard resources in this part of the lesson that can help the students learn the basics, like driving their rover forward, getting it to churn by a certain amount, and also measuring different colors on the surface. To do that, we provide some of these standard practice maps, which you'll need to print out before the lesson. These maps also correspond with the pseudocode matching cards that I talked about in the previous part of the lesson. Okay, in the elaborate section, it's time to program the robot for the actual Roads from Earth to Venus challenge course. Before they do that, they're going to need to build the challenge course. So you can see a mock-up of it on this slide. The challenge course has ramps with a standard length and width and a standard placement, and that's all described in the lesson. In this mock-up, the platform in the middle of the ramps is about 8 inches or 20 centimeters high. You can also see 3 rectangular regions, 2 on the ramp and then 1 off, outlined in blue masking tape. This is where you're going to put the color samples that the student's rover probe is going to measure. There are 3 sets of these color samples. The easiest one just has 1 color per region. The hardest one has 3 colors per region, and you'll need to pick which level is most appropriate for your students, either by grade level or their previous experience. The rover is going to start at the X, and it can drive however it wants through the course, but it's only going to have 5 minutes to measure as many of those color samples as possible with its color sensor, and it should be making RGB plots and transmitting that back to the computer via Bluetooth. And we show you how to do all of that in the lesson. In the Evaluate section, students should have already driven their rover on the challenge course for the final time. And now it's time to evaluate and document their work and also complete some things that are aligned with the mission objective 7 of the Roads from Earth to Venus challenge. So students are going to want to take time to compare the RGB plots measured by their rover to the provided key. This key shows the expected red, green, and blue values for several different types of rocks that NASA actually expects to find on the surface of Venus. So by comparing their rover's measurements to these measurements, the students should be able to identify what type of rocks they discovered on their Roads from Earth to Venus challenge course. They can document their work and you can assess it by having them write a short report that describes the data they collected, how their rover drove through the course and how long it took to collect the data, and also their conclusions about what types of rocks they observed on the surface of Venus. If you want to extend the lesson, then you can do that by having students investigate some NASA careers that are related to this lesson and Mission Objective 6. This lesson supports several science and engineering practices, including asking questions and defining problems, developing and using models, and analyzing and interpreting data. It aligns with the NGSS context standards for engineering as well, and it also connects with some computer science standards that can vary across the states. We estimate that completing this full lesson will take about 7 hours, depending on how much of it you do and your students' prior robotics experience. If you would like to make it faster or expedite it, we recommend that you build driving base 3 for each group of students before class so they don't take class time to do that. You can also make it faster by building the challenge course for the students. So again, you don't do that during class time. Great. We hope you and your students enjoy building and programming your Venus rover probe. If you need some more information, we recommend that you check out our website or you're welcome to email us at info@nessp.org. Thanks.